Here they're telling us that a cylindrical can has to be made to hold 1 liter of oil, and they're saying find the dimensions that will minimize the cost of the material and manufacture it. Well, they're telling you it's 1 liter of oil is what it's going to hold. That's talking about the volume, and the volume of a cylinder is pi r squared h, so we know that that has to equal 1. But if we're trying to minimize the cost of the material to manufacture it, I guess we're going to make it out of like aluminum. So we'd probably measure that aluminum with its surface area. And the way you measure, the formula for the surface area of a cylinder is 2 pi r h plus 2 pi r squared. So that's the thing that we're trying to minimize. So if you're trying to minimize something, you can take its derivative and set it equal to 0. But before we do that, it would be nice if we could get it down to just one variable. So right now I've got a formula that has r and h in it. I could solve that for h and get 1 over pi r squared. And then I'll just plug that in over here. So it's 2 pi r times 1 over pi r squared plus 2 pi r squared. Okay, and now I can cancel out these pi's, and I can also cancel out this r with that extra r there, and it would leave me with 2 over r plus 2 pi r squared equals s. So this is the thing I now have to minimize. And in order to minimize it, I'll take its derivative. And to take its derivative, I should probably set it up as 2r to the negative 1 plus the 2 pi r squared. And now I'll take its derivative, s prime equals negative 2r to the negative 2. Which is the same thing as putting r to the positive 2 downstairs, plus 4 pi r. All right, now that I've done that, I want to set this equal to 0. And that means I'm going to move this guy to the other side. So it's going to be 2 over r squared. It's going to be positive this time, equals just 4 pi r. And now I could cross multiply and get 4 pi r cubed equals 2. And then r should equal the cube root of 2 over 4 pi. Can reduce that a little bit, make that 1 over 2 pi. And it looks like r should end up equaling this. Now we also had to figure out the other dimension, which is the h. And we know h is equal to this. So now we just want to plug in what we just got. And that will be cube root of 1 over 2 pi. And that's actually being squared this time. And it's kind of a nasty form to leave it in because it's a fraction within a fraction. But it's kind of a nasty thing to simplify, so not sure if your professor really wants you to, but hey, whatever, let's go for it. Let's try to simplify this. Cube root of 1 is just 1, and then I'm going to square that. That would still get me 1. And then I've got the cube root of 2 pi, and that's going to get squared. So we can actually just put a squared right above that. And what that means is that the cube root of 2 pi is being squared. But now I've got 1 over something that could be written as a fraction. I can kind of merge this pi into the fraction right here. And then whenever you have 1 over a fraction, you can always flip that fraction. So this is going to turn into cube root of 2 pi squared, and I could have done that down here, put some parentheses, all over pi. So at least it's not a fraction within a fraction at this point. And those are the two dimensions. It's this one for the r and that one for the h. Those should minimize the cost. Now, I didn't really check to see if this is a minimum, but based upon the way the problem is phrased, it's a good assumption to make. Okay, so we're going to say r equals this and h equals that. Those are your dimensions. If they ever asked you for dimensions when you're doing like a rectangle problem, it's the length and the width, but here it's the radius and the height. All right, hope that was helpful.